Okay guys, so in this video, we'll be looking at a sample question for your Ujian Amali Sains for physics. The topic I've chosen here is electricity. We'll be looking at okay, let's go to the question. You're required to conduct an experiment. Siapa yang nak dalam bahasa Melayu, saya ada versi bahasa Melayu juga. Saya akan tinggalkan pautan di description huraian. Okay, you are required to conduct an experiment to study the relationship between current and potential difference of a filament bulb. Okay, so this is the experiment. So if you get the experiment in this format, this question in this format, you're very fortunate, because when they say relationship between, then what we will have is relationship between MV and RV. Usually it is in this arrangement, not necessarily always like this. Usually it's like that. Okay, but definitely it will be MV and RV. One will be MV, one will be RV. How you know which is which? You see which one you set in the beginning of the experiment, that's the MV, manipulated variable. Which one you measure at the end of the experiment, that will be the responding variable, RV. Okay. All right, so let's answer the question. State the following for the experiment. Okay, number one, state the inference. Okay, so the inference format, just a disclaimer here, we don't have any official document, okay, from LPM for the format of writing all this. Okay, so this is the format that I advise my students to use. This is a disclaimer. All right, you can follow, but if anybody got any official document giving us all the proper formats for all these things, please share with everybody in the comments. All right, okay. So this is what we've always been using. This is based on mark scheme from trial papers, so don't worry. Okay, all right. So inference. First, inference format will be RV depends on MV. This is the format. Very simple. Okay, RV depends on MV. So to answer inference, first we need the RV and the MV. So let's actually answer variables first. Okay, it will help us even for the hypothesis. Okay, what is the format? Okay, what's the format for hypothesis? Format for hypothesis is when MV increases or decreases. This is the format. Okay, RV increases, decreases. You can use this format. Okay, you can use this format if both the variables are quantitative. That means they have values. They have values that can increase or decrease, then we can use this format. Okay, if they don't have any values that can increase and decrease, for example, change in color, you cannot say when the change of color increases or you cannot. That one you have to just write one concluding statement, just the conclusion used for hypothesis. Hypothesis and conclusion same. Okay, all right. Now, so again, to answer hypothesis also we need MV, RV. So first let's answer the variables. Okay, so this one I already told you just now. And to study the relationship between current and potential difference. So what are we changing in the beginning of the experiment? Here we'll be changing the current. You'll be adjusting the current to different values. So the manipulated variable here is the current. Okay, it will be the current. Okay, how about the responding? The responding variable is what we measure at the end, measure or observe at the end. Okay, so this one, the responding variable is the potential difference. This is what we are going to measure at the end. After you set the current ready, you're going to measure the potential difference. All right. Okay, what is fixed in this experiment? What's the fixed variable? The fixed variable is the thing that must remain constant. If not, it will affect the responding variable. Okay, it will affect the responding variable. Okay, so what has to be fixed in this experiment? So here, actually, what we need to fix in this experiment, when we are using a filament bulb, what we need to fix is the filament length. Okay, this is what is used in your textbook for this experiment. You have to fix the filament length because, as we know, resistance is directly proportional to length. So the longer it is, the more the resistance, and this will affect the potential difference across it. Okay, so filament length must be constant. Okay, so we have our variables, everything done. So now we can answer inference and hypothesis. So what is the inference then for this experiment, for this particular experiment? What's the RV? You put in potential difference, but be a bit more specific. Potential difference across the filament bulb. All right. Depends on MV. What is the MV here? Current. Again, be a bit more specific. Current flowing through the filament bulb. So this is a sample answer. Again, class, this is all sample only. All right, sample answer. Okay. Okay, so you can pause the video and copy and go through it if you need. So the potential difference across the filament bulb depends on the current flowing through it. This is the inference. Okay, inference is always like this. Now you have to be careful a bit when it comes to inference, because sometimes they will give you a situation before the experiment. They will give you a situation and they will ask you for inference based on the situation. You don't give inference based on the experiment for that. Please read the question carefully. Okay, check. Inference, is it based on situation, or inference, is it based on experiment? Please be careful. All right. Okay, so hypothesis, when MV increases, so MV here will be what? MV is the current, isn't it? So when the current across, when current flowing through the filament bulb increases, what do we expect of the potential difference? Okay, class, let's do some theory here. Okay, let's do some theory here. So V equals to IR, right? Okay, when current increases, when the current increases, what we expect? Voltage will increase, isn't it? All right. Okay, so that is our hypothesis. That's our hypothesis. So when MV, like this, okay, when MV, when the current increases, this is the MV, the potential difference across the filament bulb increases. Okay, so this is MV increases, RV increases. Format for hypothesis. Just follow this. Okay, shouldn't be an issue. All right, now draw the experiment setup for this experiment. Okay, so for this experiment, the experiment setup is very simple. What we are going to do is, you need to be aware what we are doing is, we are going to change the current. We are going to change the current. How do you control current? How do we set a certain value for current? Using a rheostat. Right, using a rheostat. We will use a rheostat, adjust the rheostat, adjust the resistance of the rheostat until you get the desired value of the current. So, you know, we need a rheostat here. Anyway, the apparatus list will be given to you. Please refer to that. Okay, so we are going to use a rheostat. How do you measure the current? Because when we are setting the current, we need to know the value, isn't it? Let's say I want to set the current to 0.14. How do I know 0.14 amperes? I need an ammeter. So I need to connect an ammeter. Ammeter is always connected in series. All right. Now, what are we going to take at the end? We're going to take the potential difference. We're going to measure the potential difference at the end. How do you measure potential difference? We need the voltmeter. How do you connect voltmeter? Parallel to the component. All right. Okay. So what is the experiment setup for this experiment? This is it. Okay. This is it. Just draw this. Okay. So we have the switch, the dry cell, the power source there. Ammeter is connected, you can see, in series. Okay, then the bulb also will be connected in series. Okay, and then we have the rheostat in series. The only thing in parallel is the voltmeter. Voltmeter must be parallel to the filament bulb. All right. Okay, again, you can pause the video and take a look at it and study it. All right. Okay, now what if this is the I think one of the biggest fears for students. What if this is an unguided experiment? That means plan the experiment using the apparatus and materials provided. You yourself have to plan the experiment. How? Okay, don't worry. Don't worry. Okay, your procedure should include these methods to handle variables and the precaution steps. Okay, so don't worry. A lot of students, a lot of my students, they are very afraid because you think you have to write the whole full procedure. No need. No need. Okay. Once again, we don't have any official document giving us what you need. Okay, but to answer the question and based on some of the state trial mark schemes, okay, we can figure it out. Okay, we can figure it out. What we need to do is, you only focus on the 3 variables and add precaution. Only focus on the 3 variables. Okay, let me teach you how to do that. So for this particular experiment, let's look at the first variable, manipulated variable. So current, isn't it? So how do you make current the manipulated variable? That's what you should write. Okay, in the procedure, we are talking about the procedure. No need to write full procedure. No need to write full procedure based on the available data that we have right now. No need to write full procedure. No need. Okay, don't worry. It's only 3 or 4 marks after all. It's only 3 or 4 marks. Don't worry. So how do you manipulate the current in this particular experiment? How? So very simple. The way that you answer this is, okay, how do we manipulate the current? We use different values of current. Okay, so we use different values of current flowing through the filament bulb. And what do we do to achieve this? We use a rheostat. Okay, let me give you a sample answer. Let me give you my sample answer. Okay, so number 1, you just state different values of current flowing through the filament bulb are used. So you just say we use different values of current. We use different values of current. That's how you manipulate it, right? That's how you manipulate current, by using different values of current. Okay. Make it a good practice to always mention what apparatus you use to achieve that. So for example, how do you set different values of current? You set using a rheostat. Mention this. Mention the instrument that we use to manipulate the manipulated variable. All right. Okay, then don't just stop here. Which are, please state all the values. Please state all the values. Okay. If it's really unguided, please give 5 values. Okay. If you look through your textbook, right, every time we use 5 values. No more, no less. 5. 5. All right. But read the question carefully. There might be certain requirements in the question. Okay. But if you see nothing at all, give 5. Okay. Now, this is the first step. Okay, this is the first step. Like I said, when they ask you to write procedure, you don't need to write methodically first in the beginning. You do what, fix this, fix that, measure this. No need. No need. Not for paper 3. No need. Okay. So you just focus on the variables. Just focus on the method to handle variables. Okay. What's the second variable? Responding potential difference. Okay. So your next job is to explain how are you going to observe or measure the responding variable. How? That's all. That's all. Okay. So you want to pause and give it a try first. Okay. So how do we measure this potential difference here? We are going to measure, isn't it? We are going to measure, right? How? Very simple. The voltage, okay, the voltage across the filament bulb is measured using a voltmeter and recorded. Okay, I think it's better if you use potential difference. Potential difference. Okay, now, so once again, mention the instrument that we use. Mention the instrument using a voltmeter. All right, measured. Use the word measured. Every time you measure, use the word measured. Every time you observe, use the first word observe. Okay, so the potential difference here is measured using a voltmeter and recorded. Please make it a good habit, good practice to put and recorded for your RV. All right. Okay, so that's the second step. What's the third step? Fix variable. How do you fix the filament length? How do you fix the filament? How do you ensure that the filament length is the same? Okay, pause and try. Okay, so step 3 will simply be, all right, step 3 will simply be the filament bulb with the same length is used for each repeated experiment. Filament bulb with the same length. The same length of filament. You just state it. That's all. That's what you're doing. However, you are fixing the fixed variable, you state how you do it. That's all. Okay, that's all. So this is new to SPM, but actually this is not new in IGCSE. IGCSE, this is the way that they write procedure also. So don't worry. This is not something like it's common to write it this way. It is common to write it this way. You only need to focus on the variables. Okay, of course, we add precaution when got precaution. So this experiment got precaution in your textbook got. Okay, so what are the precautions for this experiment? Now, I'm going to give you three here because these are the three mentioned. Okay, so I think this is the easiest for you to remember. Please remember this. The connecting wires must be connected tightly. Don't be ambitious and give many precautions. Okay, one precaution is enough. One is enough. All right. Connecting wires must be connected tightly. Finish. All right. Now, second, you can say parallax error should be avoided when taking ammeter and voltmeter readings. You know what's a parallax error? Parallax error means when you're reading, okay, you read from a certain angle. So let's say this is the scale. Okay. If I look straight, I will get the correct reading. But if I look from the side, okay, I will get wrong reading. I will get a bit smaller. If I look from this side, because of my line of sight, my reading will be a bit bigger. So that's called a parallax error, right? So you want to avoid the parallax error. How do you avoid the parallax error? Ensure that your line of sight is perpendicular to the scale from which you are taking the reading. Make sure your line of sight is perpendicular to the scale. Right? Okay. Now you don't have to explain all that. Don't worry. Just say parallax error should be avoided when taking ammeter and voltmeter readings. Right? Now, I always advise my students, if you forget any experiment related to electricity, okay, any experiment related to circuit, if you forget precaution, you can use this. Switch must be turned off immediately after each reading is taken. Now, I want to stress here, this point in the textbook is only used in context of the constantan wire. Okay, because the reason given is, you should state the reason lah. The reason is to avoid the constantan wire from increasing in temperature. That means to keep the temperature of the constantan wire constant. Okay, so that's the precaution stated in the textbook. So for this particular bulb experiment, I wouldn't use this lah. I wouldn't use this. Okay, I would stick to this. Connecting wires must be connected tightly. That's good enough. This is the precaution. Okay, so that's it. This is your procedure. This is your procedure. 1, 2, 3, 4. Finish. Finish. Of course, you don't write like this. Please don't write like this. Write 4 here. What I've given you a few options. That's why I put it like that. Okay, that's it. Don't worry about unguided. Don't worry. Okay, don't worry. 3 or 4 marks. Finish. Okay. Next, tabulate the data from the experiment. This is very important. So how do you tabulate the data? So the standard format will be first MV, first column will be MV, second column will be RV. This is the standard format. Anything else that you observe and record that is not MV and RV, anything else that you measure and observe in the experiment must also be tabulated. Must also be tabulated. If you are doing any calculation, sometimes they require you to calculate the resistance based on the current and the potential difference. Calculation, then you must also include in the table. Okay, so here now. So here, this is it. Okay, so current. Now, please remember your unit must be in the header. Some tips for this table. Your units must be here. Your units must be here. So ampere, volts here in the header. In the header. Please do not write it here. No, wrong. Okay. Your reading must be consistent. 0.14161820. Can you see 20? Not 0.2. Your number of decimal places must be consistent all throughout. Okay. When you take reading with the voltmeter, it depends on what voltmeter you're using. If you're using an analog voltmeter, most likely the smallest reading you can take is 0.1 volts. Check your voltmeter. If this is true, if the smallest reading you can take 0.1 volts, then all your readings, for example, let's say I got 2 volts. So 2, wrong. 2, even if you get 2, you write 2.0. Make sure you're consistent with everything. Everything must be one decimal place here, all the values. Okay, so these are your tips for your table. All right, this one is a very simple table. Okay, next, drawing a graph. So when you plot your graph, of course, we didn't do the experiment. I don't have any values, but theoretically, I can tell you this filament bulb, okay, filament bulb is a non-ohmic conductor, non-ohmic. So non-ohmic conductor, what does the graph look like? Very simple graph. Actually, this one is a little bit more complicated than ohmic, but non-ohmic conductor, the graph is curving upwards, right? So this is the graph for non-ohmic conductor. Okay, so it's a smooth curve. It's a smooth curve. Okay, don't try to draw a line of best fit here. It will be wrong. Okay, because a filament bulb is non-ohmic. You're not supposed to get a straight line, but we do start from the origin. We do start from the origin, but you're not supposed to get a straight line. You are supposed to get a line that's curving upwards. Let me explain a little bit. That's because when you increase the current, okay, the temperature increases. When temperature increases in the filament bulb, the filament itself, the temperature of the filament will increase. When the temperature of the filament increases, its resistance increases. How do you get resistance from a VI graph? Resistance is V over I, isn't it? So in this case, it would be the gradient. So what's supposed to happen to the gradient? As the current increases, the gradient will, let me show you. So the gradient at this point is the tangent, gradient of the tangent here. But the gradient at this point is like that. Can you see? The gradient is increasing. The gradient is increasing. So it's curving upwards. Okay. So let's say based on this graph that you have drawn, state the relationship. State the relationship between V and I for filament bulb. So what is the relationship? How do you state this relationship? Very simple. V, this one, the relationship is V increases with I. Okay, V increases with I. Just increases. Not directly proportional. Directly proportional must be a straight line passing through origin. Just increases. V increases with. Okay. Right. This is also not linear because it's a curve. Okay, last one. State the operational definition for potential difference of a filament bulb. Okay, this is a bit. If any of your teachers or anybody has given you a particular format, please share in the comments. Let's help each other out. Everybody help everybody. Okay. The problem is operational definition for physics is new. All right. So we don't have a lot of information. We don't have a lot of samples to follow. Okay. Some of your teachers, I think most of your teachers in school wouldn't have even given you how to write operational definition for physics. It's not their fault. It's not your fault. Okay. Because this is something that chemistry and physics, chemistry and bio, we always have. Physics is a bit new. Okay. So based on the data that I have collected, okay, based on data I collected, I've used some trial paper sample answers this year as well. Okay. The format seems to be like this. Okay. So the format seems to be like this. So you can say state operational definition for potential difference of filament, right? So you can use this format. So you start with whatever they want you to define. So you start with potential difference of filament bulb. Okay. Okay. Then the format is like this. You can use is shown by. This one is actually borrowed from bio. Okay. You can use this. Is shown by. Okay. The most important thing for operational definition for all the subjects is what you observe from the experiment. How are you collecting the data? What are you observing? Either you measure or observe lah. Is it a change in color? Is it a becoming cloudy or becoming? Those are the physics and the bios lah. Okay. So here, or is it some sort of measurement that you are taking? So in physics, usually it's the measurement lah. Right? So what are you measuring at the end to collect the data, okay, related to the RV? What are we measuring? So here we measure the potential difference, isn't it, for the RV, right? Now, you don't put potential difference. You don't just put RV here. It must be what you actually observe or measure. What did you observe? What did you observe? How did you get the potential difference? How? It's shown by the voltmeter reading. This one specifically, the voltmeter reading is what we actually took from the experiment, what we observed. Now, in this case, what we recorded. All right. Okay. I really hope that makes sense. I really hope that makes sense. You can ask questions in the comments. I will try my best to answer as fast as I can. Okay. I'll be preparing one for chemistry and bio as well. So you can subscribe to the channel and just so that you don't miss it. I'll upload it as soon as possible. Okay, guys, all the best to you. Okay, please be careful, read the question carefully. Don't expect the question to come out exactly like textbook. Please read the question carefully. Read the question carefully. If you got graph, please work a bit faster because you don't have time. Time is your biggest enemy. Okay, all right. Look for the theoretical question. If you think your experiment is failing, you think it's done, you really feel like you don't have enough time to complete or whatever, never mind. Look through the paper, there should be at least one theoretical question. There should be, okay? Look for the theoretical question, get your 2 or 3 marks there. 2 or 3 out of 15 is a lot, All right? All right, guys. All the best.